Hey guys, welcome back in. Mr. Marone here. Before we get started on our third and final rigid motion, quick shout out to my Period 2 class who are very patiently waiting outside my room as I record these videos. So good job, way to be patient. Sorry you're having to stand out in the hallway. So we are into our last of our three rigid motions. We first looked at reflections, then we looked at translations or slides, and now we're going to look at rotations. So a rotation, I'm going to circle the very specific transformation rule that's given for rotations. So when we deal with a rotation, it's always a lowercase r. With reflection, it's uppercase, rotation lowercase. And then the way that you're going to tell it's a rotation is that they're going to give you two pieces of information in the subscript, in the little letters below. The first one is they're going to give you a degree measure, and that's your degree of rotation. That tells us how far we're going to rotate each individual point. And then the second thing they're going to give you is a point, and that's going to be our center of rotation. That's going to be the point we're rotating the figure around. You have to have both of those in order to perform a rotation. So it's important to make sure that we keep that in mind as we look at these. So a reflection only gives you one piece of information, the line of reflection. A rotation, on the other hand, is going to give you two. So there's another way to determine which one's given, a rotation or a reflection. So with that, I first want to just give an example of what this looks like, and then we're going to take a look at some rules that are already given to us for free. So the first one they gave us is this triangle XYZ. They want us to rotate it 75 degrees around point P. One thing I want to note before we do our rotation is that when you're given a positive degree measure, like 75 degrees, when it's positive, the rotation is counterclockwise. It's counterclockwise. Sorry about that bell, guys. Make sure that you're rotating the correct direction. So if I'm going 75 degrees, I'm actually going to go to the right, not clockwise like we're used to doing. So just keep that in mind. So to perform this rotation, I'm going to draw a line from each of my 3 points to point P. And what I'm actually going to do is change the colors here. So I'm going to make X red. I'm going to make, Y red. I'm going to make X blue. And I'm going to make Z green. So from there, I'm going to rotate 75 degrees to the right. So what you're going to have to do when you don't have a coordinate plane or anything like that is you could use a protractor. I'm just going to do my best guesstimate here. So 75 is just a little bit less than 90. So there's Z prime. Change colors. There's X prime. And there's Y prime. And if you notice from our rules above and then from my diagram here, every time the distance between the point of rotation and your initial point, your pre-image point, and your image point are going to be the same. So YP and then Y prime P are about the same length. I'm guesstimating here. Same thing with X and X prime and Z prime. So there's an example of a figure being turned counterclockwise 75 degrees. The nice part is that the vast majority of the time we're going to be in a coordinate plane, and with that we're going to have some rules to work with. So they've given us 3 rules, and these are best to be memorized. So in each one, you take your original coordinate points and you perform some change to them. So in 90 degrees, you switch your X and your Y coordinates, and then you make the original Y coordinate negative. With 180 degrees, you just make both points negative. You change their sign. If they're negative, you turn them positive. If they're positive, you turn them negative. And then in 270 degrees, you flip the X and Y coordinates and you turn the original X negative, or change the sign on that one. Notice that all 3 are around some point O, which is known as the origin, around the point 0, 0. So let's take a look at 2 examples of this. The first one is they want us to take this quadrilateral and rotate it 90 degrees about the origin. If you haven't memorized the rules yet, that tells me that xy is going to become negative yx. So the first thing you're going to want to do is write down what the coordinates are for each of those 4 points. Okay, once we have them, you're then going to perform your transformations. What I recommend doing is flipping the coordinates first and then changing the sign on the original one. So we can look down the line. 3 of these original y's were positive, so you should have 3 negatives. One of them was negative, so we should have 1 positive. So point A is going to be flipped to 5, 3, and I'm going to make the y coordinate negative. And I'm going to repeat that pattern for all 3 of these extra points here. Okay, so I've got my 4 points. All you have to do now is just plot the points. And there's my figure turned 90 degrees counterclockwise around the origin. Now, the nice part about this is that as much as having a graph is a wonderful thing, it gives you a frame of reference, when it comes to rotations, they're actually easier done algebraically. So here they've given us 3 vertices, they've given us x, y, z, and they want us to rotate this figure 180 degrees. Our rule for 180 degree rotation is that x, y becomes negative x, negative y. We just change the signs. So if I've got point x at negative 4, 7, I'm just switching the signs. That becomes 4, negative 7. And I'm going to repeat that pattern with both y and z. And that's all you have. That's it. When you are given the points and they ask you to do a rotation, as long as it's 90, 180, or 270, those 3 standard ones that we look at, you just use the algebra. You just flip those signs, and we ended up with the points 4, negative 7, 0, negative 8, and negative 2, 1. If you guys have any questions, please bring them into class, and we will answer them. Otherwise, have a wonderful night. See you guys.